So this question is about samples and dilutions and how you would deal with that if you get one in a titration question. So here I have a roughly 100 centimetre cubed of an aqueous solution, whether it's an acid or a base doesn't matter, and I'm going to tip out 20 centimetres of that. So I had 100, I tipped out 20. Just have a little think, in my sample, so this smaller volume that we've tipped out of the bigger volume, we call that the sample. In this, is there the same number of moles that I started off with, or less, and why? So if you pause the video, have a little think about that, and it's the why that we're really interested in. Do I have the same number of moles in my sample that I had in the original solution, and why? Okay. So the answer is you will not have the same number of moles. So if I represent 100 centimetre cubed as 5 little beads, so here's my 100 centimetre cubed of solution. If I tip out 20 centimetres cubed, I'm tipping out a fifth. There we go, tip. So you can see with samples, you end up with less moles in the sample than what you started off with. That's how samples work. What we can also have is a dilution. So in a dilution, I have my chemical, and then I add water to it. So if I was to add water to this conical flask, would it change the number of black beads in there? No, I'd still just have one black bead, right? I'll do it now. Let me add some water. There we go. Look, there's still only one black bead. Adding water does not increase the number of moles of chemical. It increases the number of moles of water, but not the moles of chemical, not the moles of acid or base. So dilutions do not affect the number of moles. So to sum that up, bear with me while I readjust this. To sum that up, will it change the moles? Samples absolutely change the moles because you're tipping out a smaller volume from a larger, but dilutions do not change the moles. If I add water to a bathtub with a marble in, I've still only got one marble. Now, when you're doing a titration question, you should be working in moles. The first thing you should do is find the moles of something. So if you notice your question has a dilution in it, you added water to something, it doesn't matter. You can just ignore it. You can literally ignore that step, because dilutions do not change the number of moles. However, if you notice that your question has a sample in, so you had a large volume and you tipped out a smaller volume, you absolutely need to take that into account. So to go back to the question from the previous video, and if you've not watched that video, stop this now and watch it. So here is our question from the previous video, and we drew our storyboard, our diagram to show what was going on. We noticed in this previous question we had a sample, because look, we started with a large volume and we tipped out a smaller volume. How are you going to deal with this in a question? So just to use simple numbers, let's say you found out there was 7 moles of chemical in here. I know that isn't what the answer to this question is, but just to keep it simple. If we had 7 moles in our conical flask, how many moles do we have in the original solution? So what we're going to need to do is a sample factor. Now the sample factor is big V over small v. So that's something to stick on a flashcard. Remember that. That's how you deal with samples. So in this question, my big volume was 250. My small volume was 25. 250 over 25 equals 10. That tells me there was 10 times more stuff in the big thing than the small thing. So if I want to go from my conical flask to my volumetric flask, I would need to multiply by the sample factor, which in this case is 10. So I would do 7 times 10, which gives me 70 moles in here. So the bit to remember, here's what I would like you to get on a flashcard. Sample factor equals big volume over small volume. That will give you an answer. Whether you multiply your moles by the answer or divide by that answer depends on which way round you're going. If you're going from the small volume to the big volume, you multiply. If you're going from the big volume to the small volume, you divide, because you'll always have less moles in the smaller volume. Okay. If you've got a dilution, the thing to remember is they don't affect the moles of chemical. They will affect the concentration, but you shouldn't be working in concentration. You should be working in moles. So you can just ignore it.